Hello everyone, we are team passengers and we will be talking about our solution for the problem statement title Innovative Application of Cloud Optimized GeoTip for Inset Satellite Data, and the theme was Clean and Green Technology. So let's start with the necessity to develop a solution for this problem. So we know that satellite data are large, very large data, and if you want to use for a certain use case, we needed to download the entire data, which requires a large bandwidth, and also there is a storage constraint, and there is no availability of fly manipulators, so on the fly manipulators. So and existing tools that are available to solve this problem do not have COG or cloud optimized GOT information, so which restricts the metadata. Now what we are proposing the solution for the prototype in this seven objective, or in these seven checklists. So first we will optimize the insert data for cloud, that the HF5 file or the dataset which we have received, we will first unpack it and separate all the data streams in different format. Now we will encrypt them in different format to ensure that the encryption is in such a way that that can be live streamed. So as we have also mentioned in the second point, that we will enable the selective streaming. Now let's say the user is asking for the hyperspectral data of certain ports, certain locations. So we will selectively stream the hyperspectral spectrum or the channel of that the whole data. That means we don't need to stream the whole data. That means there is a save of bandwidth. Now we will also give real-time data tool, or we will give the on-the-fly manipulator tool. What it will do, that if the user is let's say zooming into the location, or moving over to other location, or let's say he wants to switch from point data to, let's say he wants to switch from the heat map, then all these features we will give to the user, and whenever user will switch them into, they will be able to switch between this visualization mode. And after that we will be using the cloud based platform. So as I have earlier mentioned, that we will be encrypting all the data, and as the problem statement also suggested, that we have to use the geotip format and store into the cloud structure. So we may use AWS or similar type of cloud structure. However, we will be using some cache technology, let's say the Apache cache technology, to give the on the fly manipulator. Now what we will do, that we will design a intuitive user friendly interface, so users from metrologist or to government agencies or non technical people, everyone can access this and use this data. And as we have mentioned, that we will support partial downloads. So in this way, what will happen, that at a place where there is low internet, there also the data can be accessed. So here is the flow diagram of the data. So first, from the satellite, the data will be collected, and that will be pre-processed. After that, the data will be acquiesced, and it will be passed through the COG generation pipeline. Now this COG generation pipeline will after passing the COG data into the COG generation pipeline, the data will be stored in the COG storage. Let's say it may be Google Cloud or AWS Cloud, and after that the data will be real-time processed, and the fly band color and arithmetic adjustment. After doing this fly band and arithmetic color adjustment, the data will be visualized based on the user input. We will select the selective streaming will be occurring, and the real time processing will be done of particular data that user is has asked for. And based on the user input, the arithmetic color will be adjusted, or the fly bands will be adjusted. Now let's say that data visualization. So as mentioned in the flow diagram, users request satellite data visualization and choose visualization format. Let's say it can the data can be discretized data, or can be path, or heat map, or intensity. Now after that, we will process the data and visualize using some tools like Restudio, Folium, Plotly, and after that, output will be delivered to user. And based on the user's feedback, maybe user wants to zoom that, or may want to navigate it somewhere, based on that the data will be further updated. So that's what we have mentioned in the user feedback loop. And in use case example, we have already mentioned that we will be using the point line heat map register. So and let's go to the next slide. So here is the technical stack. So for data acquisition and pre-processing, we will be using request, gdal, pandas. And for cog generation, the libraries that we will be using is numpy, h5py, rasterio. Now for on the fly manipulation, the front end technology that we'll be using is react and plotly. And here for backend processing, we'll be using Django and SIPy matplotly. Now for the user interface tool, we'll also be using the dash to build the analytical web application. And the storage system that we'll be using, AWS, Google Cloud. Blob storage will be using, and also Apache Kafka to for stream catching. So as it can be seen that there is one satellite data, and it has different bands and different informations are there. And based on the user's query, will say, specific band will be streamed. And before that, all the data will be encrypted in a compatible format so that they can be streamed. And on the fly manipulation, the data can be switched. And here is the types of visualization. So we will be giving the point data visualization for displaying discrete measurement. This will be line data visualization, and also the heat map visualization. And there we will be giving some contours, maps, and time series animations also. So so let's talk about the challenge and strategies to develop this solution. So handling massive satellite data volumes in real time is tough. That is why we will be converting the data into cloud optimized geotips to enable efficient streaming and selective access. And after that, we will be using limited infrastructure for real time data processing. We will use cloud based storage and scalable API to enable fast on demand data retrieval. And the next challenge is difficulty in assessing specific data regions or bands without downloading the entire dataset. So here the strategy is to implement a selective streaming API to allow users to access only the required region or bands. Next challenge is complexity in real-time satellite data manipulation. So we will be developing some tools which will support the on-the-fly data processing. And there is also a challenge that lack of custom processing options for advanced user. So we will be using a user-defined algorithm integration directly into the system for tailored data analysis. Now what is the innovation in our solution? So first we will be using we will be providing AI assisted data processing. We will be leveraging AI and machine learning for automatic anomaly detection, cloud masking, and feature extraction from satellite data. Now we will also give the smart data catching and implementing a intelligent catching to preload frequently accessed data regions or spectral bands. Users will experience faster retrieval times. And we will also use the dynamic band fusion. So as you have already mentioned that there will be on the fly fusion. So based on that, if we fuse different type of bands, what happens that we can get more informations, or we can apply for it some different use cases. As we know that one specific band can give certain type of data, and other specific band can give a certain type of data. If we can fuse their total data, or if we can fuse their combined data, we can interpret more informations, or we can increase the use case, or we can use this in for more purposes. So and this we will also use a added a real time collaboration systems. Let's say if some scientists or workers are working on certain type of project with our solution, then we will also use the real time collaboration system, so that they can invite their members or other members, so that it can be used as a collaborative platform also. Now let's talk about the impact and benefits of our solution. So as you have mentioned, there is faster data access, improved efficiency, scalability, cost reduction, enhanced data usability, better decision making, wider access. So here are the some of the use cases of our solution. So cyclone tracking in the Indian Ocean. So first, the necessity is real-time access to selective regions and band to track a developing cyclone without downloading the last dataset. And our solution is that cloud optimized geotips enable selective streaming and on-the-fly manipulator for rapid weather analysis. Similarly, agricultural monitoring for drought. So let's say there are vegetations, and some vegetations are need water, or some vegetations are malnutrition. So we know that radiation is the material property. So from satellite data we can get the idea that on a large scale, let's say agricultural land, what is the state of the vegetation, are they healthy or not, that kind of information we can get from the satellite data. So here is the solution, that selective streaming of on the fly NDVI analysis from cloud based cogs ensure timely agricultural monitoring. And for as we know that forest fire detection in the western ghats, so COG based selective streaming and manipulation of infrared bands enable fast and fire detection and alert system. Similarly, climate change research by any university, so COG based access to archive data in the cloud allow for scalable research and long term trend analysis. So thank you, this was all from our side, and we would like to mention the research and references. So thank you.